Hi everyone, my name is Anvita Bansal and let's get started with our today's lecture. So from our SD sheet, stacks and queue topic, the question that we will be discussing today is LRU cache. So this is a very nice problem. Let me just check before we move on if I'm live or not. I think we are live and good to go. So let me move to the question now. So what does this question say? You need to understand the question very well. So in this question, you have to design a data structure that works like an LRU cache, where capacity denotes cap denotes the capacity of the cache, q denotes the number of queries. Queries can be of two types: set xy, get x. I'll explain you in detail. Let me just quickly find out if my screen is visible to you guys. I think we are. Oh, good to go. Okay. So I'm sure you must have gone through the question, but let's understand what the question says. So guys, LRU cache, you have to design a data structure that works like an LRU cache. What do you mean by that? Let me just explain to you. So in layman terms, let me explain to you in this way. When we use a mobile, okay, when we use mobile apps on mobile, anything, then we get some home tab, right? On in home, we get lots of tabs that have been opened, right? There are lots of tabs that get open. For example, let's say I opened camera, then I opened Chrome, okay, then next thing I open it can be anything, calendar, let's say, and then I open calendar, I opened what can it be, photos, okay, let's say. So what happens is, the one I opened in the very beginning, that can be found here. The one which I opened very recently can be found here, right? So if I have to remove the very recent app that I opened, it will be photos. First I will remove photos, only then I can move to the next one. And that's typically what you need to do. Okay, I can see people here. Okay, visible, cool. So this is just to give you a little glimpse of what we are going to actually design today. The data structure that they want us to make is typically this kind of. So that was in layman terms. Now let's understand exactly what your question wants you to do. So 1 second. Coming back to our problem. So in this problem, you will have to complete two functions. One is set xy. Here it is already I have coded, so you will see. But yeah, so this is the function that you have to complete, in which you will be given two inputs. One is x, other one is y, that is key value pair. So the apps that I was talking about, you can relate them with a key value pair. Okay, so I am inserting, instead of these camera photos and all these things, I am inserting a key value pair. Let's say 1 corresponding to 5. First I inserted this. Okay, then next, let's say I inserted 2 6. Next, let's say I inserted 4 8. Okay, so these are some key values pairs that I am inserting, that will be completed, that will be done using set function. Okay, this function is responsible for inserting the elements which are in the form of key value pairs. Got it? Okay, now there are certain things that you have to understand. One thing that they have given you, that there is a total defined capacity, that at a time maximum these many key values can be stored. So at any point in time, if let's say I keep calling set function for n number of times, but wait, at any point in time the maximum number of such pairs that can be stored must be maximum, they can be equal to capacity, that is denoted by cap here. If your question says that cap is equal to 2, that simply means that you cannot store more than 2 key value pairs at a time. Now next thing is, what if I want to store more elements, more key value pairs? Then clearly you will have to get rid of some key value pairs, or if you are adding one key value pair, then you have to get rid of another pair which is already existing in your data structure, in your LRU cache. So how will you remove? Now they have said, the question tells you that when you get such a condition, then you have to remove that pair that has been used, not the one that has been recently used, but the one that was previously added into your cache. Got it? The pair that has not been used very recently, the one that was added in the very beginning. So let's understand using the example here. I hope you got the gist of this question. Let's say these are the queries. This is your capacity. You have got 8 queries. Let's see what can we do in this question. Okay. Where is it? Not this. Let me take this here. Now you will be able to understand what we actually have to do. So these are the total number of queries that you have to perform, and let's start doing performing these queries in our data structure named LRU cache. Okay, so how our cache is going to look like? Let me make a box like this. Okay, let's not. Starting off with set 1 2. So you have a pair of 1 2 right now in your cache, right? This is my cache. Next pair that you are inserting in your cache is, next pair is 2 3. This is set 1 2. Then now I am at set 2 3. Now next pair is set 2 3. Now what you have to maintain here is that you also need to know which is the element that was most recently used. So this is the most recent used element. So let's do one thing. I will represent the most recently used pair here and least recently used towards the right. So let me just swap it like this. Whichever new element I am adding, I'll be adding it here. So the most recent one was 2 3. Got it? That was 2 3. You can do it either ways. I have implemented my code in such a way that I will be getting the most recently used pair right in the beginning. So I am doing it that way to explain you. The next element, the next pair will be the pair that I added in the beginning was 1 2, right? And after which I added this 2 3. I'll tell you why we are making these arrow signs. You will understand it better. First, let's see how we are inserting them. Okay. So I inserted 1 2, then I inserted 2 3. Now I have to insert 1 5. So I will insert 1 5 here. Okay. But wait. Now why I am telling you to stop here? See, the capacity of this cache is 2. That means at max you can have maximum 2 pairs. So definitely you will have to get rid of one pair, and the pair that you will be getting rid of will be the one that is present in LRU, that is present at the least recently used position. Okay, so this was the most recently used pair, so the least recently used pair is 1 2. So you will get rid of 1 2. Okay, and you will add your 1 5 where? Here, right? The most recently used position. You getting this thing? Okay, fine. Now next element is 4 5. I am setting 4 5. So I will check the capacity. The capacity is already 2. So I will be removing the least recently used one. So now I will be getting rid of which is the least recently used. Now this is your LRU. This is the one that is least recently used because this has been recently added. So I will get rid of this, and the one that I will be adding now is, which one we are talking about? 4 5. Okay, so 4 5 will come here. Got it? So this is your 4 5. Next, what? Now your cache is this, where this is your most recently used one and this is your least recently used one. Got it? Okay. Now coming on to next one, let's set 6 7. In order to set 6 7, I will be getting rid of this and I will add my 6 7 here. Okay, fine. Then next is get 4. Now when you call get function will ask, do I have a pair whose key is equal to 4? Yes, in my cache right now your cache only consists of these two elements. Got it? So do I have in these elements, do I have a pair having key as 4? Yes, I have. So I have to return what? I have to return the value. Okay, let me just check it. So when you are asked for these, you will be returning, whenever you are calling your get function, it prints 5. That means you are printing the value of that pair. So my cache contains 4. So my get 4 should be returning me 5. Okay, so I'll get 5 from here. Now one more thing that you have to take care of, you all saw that right now I just called get function. You got it? I just called get function. So that means I made a call to this tab. For example, now I'm talking about that phone. I just made a call to a tab that was previously opened by me, but I again opened that tab. So that tab in my home will appear in front. That means it will become the most recently used one. So when you call get function and you found a pair containing that key, that means I just touched it or I just opened this tab again. So instead of being here, it will again take its place in the most recently used position. You're trying to understand this point? This is something very important that you need to understand, that when I'm calling, when I'm setting my values, when I'm setting my pairs, I am making sure that the one that that I'm trying to add, it comes in the beginning of whatever data structure I'm using here. But when I call a get function also, in that case also what happens is, if I found a pair having that particular key, I will return its value, but simultaneously I have to make sure I will shift its place if it is present in the least recently used. Even if not, I will make sure that I just use that particular tab. So I will bring it back in the beginning of my data structure so that I can know that now this is your most recently used and this one becomes your least recently used. And since this cache is supposed to hold only 2 pairs at a time, so right now your cache is about 4, 5 and 6, 7. Okay, let's move to our next query, which is setting 1, 2. So if I set 1, 2, I will have to get rid of least recently used 1 and I will add 1, 2 here. Got it? Now 1, 2 becomes here and it points to 4, 5 and your most recently used is 1, 2 and least recently used, this is MRU and this is LRU and this is your cache. Okay, now let's talk about another query, that is get 3. So do you have a pair having key as 3? No, I do not have. So you will return -1 for this particular query. That's about your this test case. Now I think you understood the question. Now we will move on to understand how are we going to implement this thing. So just give a little bit thought. I am sure that you might have understood by now that maybe you got a hint what we are going to use, but just give it a thought. Meanwhile, I'll just show you that, see, this was a test case that we used for this explanation and you got output 5 and -1 that you got from get function. You called get 2 times. One time it was for 4, one time it was for 3. For 4 it returned you 5 and see what was the condition in every time. When you set, so in this explanation or for this particular problem, they have done reverse thing. The reverse thing is that we are storing the most recently used in the beginning. They are representing you the most recently used one in the end. That means I added 1, 2, then I added 2, 3. So in our explanation, 2, 3 is coming in beginning. For them it is in the end. That is in the rightmost place. So that is something a little swapped. So the concept should be clear. You can do the question either ways. Now how can you do this question? Let's understand that point. Okay, so let's see. So which data structure comes to your mind when I talk about keeping track of my previous pair also, or maybe anything, previous element, my next element? How can I do this thing if I take an array? Okay, I'll be calling on the indexes. That will take me whole iteration to get my previous element and to get my next element. So can I do something better? If I take any data structure which can get me its previous value also and its next value also in O1 of time, let's say, is it possible? Yes, it is. If you are aware of linked list, then this thing can be done easily using doubly linked list. So here we are going to use doubly linked list because we want to get the address of the previous node as well as the next node. That is the reason we are using this doubly linked list, so that we can get this task done in lesser time complexity. Okay, that's our first reason. Second thing is, now since I'll be using this, but also I have to, you can see that what I am storing in my linked list. So linked list will be containing a node Okay, node pair, you can say it can be of type node pair. We all know that how is it. So linked list, let's say we will create a class linked list which will be having node next, okay, which will be pointing to its next node. It will be having node previous, which will be pointing to its previous node, and each node will be having some key value pair, int key and value. Got it? And then we will initialize them. So this is the kind of, this is how our nodes are going to be represented. Each node will have pointer to its previous value and its next value. Also, it itself will be storing a key and a value. Got it? That's how we are going to represent a linked list node. Fine. Next thing is, I will be also, now tell me one thing. When I'm making call to get function, it is returning me the value corresponding to that key. So for that case, I should be having some map, hash map, which can give me the value in O1 of time complexity. So I'll be also creating a hash map, not creating, I'll be making use of hash map of type integer, which will be storing my key value pairs. Got it? Fine. Now let's see how are we going to do it. So you have this class LRU Cache. Fine. What is it? Typically, if I were to talk about explanation part is done. Now let's see how using linked list are we going to get this question. Are we going to solve this question? So let's see. Each of these pairs are stored in a linked list. Means I have created a node of these pairs and my hash map will be having the key value pair. So let's say when I am making call to set 1, 2. So first of all, I will ask my hash map. Does my map contain 1, 2? No, it does not. I'll add this key value pair into my hash map, and also this is your head node. Now let's see how it is going to look like actually. Let's say this is your head node, okay. It will have some address and it will be pointing to the node which I am just adding, that is most recently used node. Okay, this is your head node. Fine. And it will be pointing to the node I just pushed it. So what is the node that you have pushed right now? That was 1, 2. Okay, so I just pushed 1, 2. So this is the node having key value pair. Okay, and you just push it into your no. Now this, since it is a doubly linked list, so this head will be pointing to this node and this node's previous will be pointing to head. Okay, and obviously heads here will be null. Now this is your most recently used one. Now then what is the next node you are adding? The next node that you are adding is 2, 3. So when you are adding, when you are inserting a node, basically you will be calling set function. So set function's task will be to first check if your map contains that particular key or not. So 2 is not present, map does not contain. So what it will do, it will insert that value in your map as well as in your node in the linked list. Okay, so 2, 3 will be added into your map and in your linked list on the basis of that it does not exceed the capacity. So far the capacity is not 2. So now the next node that will be added right next to it will be 2, 3. Whose previous will be this node and its next will be this. And since I told you that we are maintaining this in all of this in such a way that, just a second, 1 second. So we are maintaining the nodes in such a way that the most recently used one will be found right next to head and the least recently used one will be found right previous to the tail. So this is your tail node. Okay, this is your tail node. Just for representing I have written like this, and its next will be tail, tail's previous will be the least recently used one. Okay, but I think I made a mistake here. I have to write it this way. Your 1, 2 was the least recently used one, so it will come here and 2, 3 will go there. So 2, 3 will come here and 1, 2 will come here, right? Now coming on to the next query. The next query is set 1, 5. So I will ask my map, do you contain a key value pair with key 1? Yes, it does contain. So first of all, it will remove this from your map, because whenever I found a key value pair with the similar key already, I will remove the previous one and update its value. So first of all, I remove it from here, and the one that I have in my cache already, I will also remove that from my cache that is already present. So this will be removed, and now what will happen, that instead of being at the LRU position, now it will come at MRU position with the updated value. So what is the updated value of this? 1 5. So 1 5, your map will be containing 1 5, and this 1 5 will come here, 1 comma 5, and 2 3 will go here. So the most recently used one has become least recently used one, and 1 5 has become most recently used one. So I'll just write it nicely so that you can see 1 5, and this will be your 2 3. Okay, 1 5 and 2 3. Next is what? Next is 4 5. Again, since you are at the maximum of the capacity of your cache, so you have to remove the key value pair. First you ask your map, does my map contain 4 5? No, map does not contain 4 5. You add this key value to your map so that whenever you call a get function, you can get it in O1 of time complexity, and then you will remove the least recently used one from your cache and bring it to the most recently used place, right? So how is it going to look like? See, this node actually gets deleted, the least recently used one gets deleted, okay, and this one starts pointing to tail. Ideally what will be happening in code, that is what I am telling you. So this will be start pointing to your tail, and the one that you are trying to add, which is 4 comma 5, it will take place right next to your head. So a new node will be created here with key value pair 4 5, whose next will be this, okay, and its previous will be this, and head will be pointing next to this pointer, this node, and this node's previous will be this head. So I since although this question has been put up in stacks, but you need to have a good grasp of linked list. Actually, ideally it's a good linked list question. So if you understand this thing, although I have pretty much explained also, even if you have not much idea, I'm sure you'll get it from here. So this is actually what might be happening when we are inserting a new node. So this is all about inserting. Okay, next is 6 7. So 6 7 is already not present in your map. You will add it into your map, and this will be removed. This 4 comma 5 will be pointing to tail, and a new node will be added, 6 comma 7, which will be pointing right, which will be right next to head. That's what is happening. And 6 comma 7's next will be 4 5. Okay, now next is what? Get 4. So get 4 will be asking your cache, your map, do you contain 4? Map will say yes, I do contain 4. So I will return the value 5. Fine, that's what I'm doing. And simultaneously, whenever you are removing the key value pairs from your cache, you also remove them from the map. Okay, so that is what you have to do whenever we are doing this remove process. You are also simultaneously removing it from the map. So this is also not present, 1 5 is also not present right now. Only I have is 4 5 and 6 7. So that is all about how we are going to perform these operations in a doubly linked list. Now let me just check if you guys have any doubts. You can write in the chat. I can see it here. So let's see if you guys have any doubts. I think it is clear so far. So okay, let's move to the code now. Let's move to the code and try to understand the things that we have discussed. Let's try to understand it, how we have implemented, right? Okay, so in this question you will be given this set function and this get function to implement. You have to implement them. So let's start with my set function. Set has two key value pairs as its input. Okay, now before we move ahead, since I told you I am creating a doubly linked list. How do you create a node of a class node for a particular linked list? So I told you, since it's a doubly linked list, I have two nodes. One is next, one is previous, and each node comprises of a key value pair that is of type integer. Now this is the constructor for this class node, which is initializing these values, and that's how you have created a node class for your linked list. Now starts your function, your class LRU Cache. So I am starting with head, since I will be having one head node, okay, one tail node, okay. One thing that I have not told you before I move to the code, that in your map actually I will be storing key and the corresponding address of the node. That means the node address, that is their unique values. I will be storing key and not the value but the address of that particular node. That means key and node, key and that particular node. So this, when I'm adding this node, let's say 6 7, so the key will be 6, but this node must be having some address, so that node I will be storing in my map. Okay, so you see my hash map is of type integer and node. Got it? Then capacity has already been given for you, or you can take int capacity. I have taken int capacity. Head, you have initialized your head node, you have initialized your tail node, right? That's how we are doing. We have created a hash map. We are creating a hash map of type integer and node, right, by the name map. Now let's start with this. So before I move ahead, this get set function you have to complete, but before that I am creating another function, which is, one second, I think it was, let me just check how was it given previously. Okay, so you will be given this as well, LRU cache in capacity. So I am initializing, this is the argument, so this dot capacity is equal to cap. This is your LRU cache constructor in which argument is capacity, and here itself I am initializing my hash map that I created above, and given these next and previous, I am pointing my head dot next to tail and tail dot previous. That means my tail's previous is head. Right now what it shows, that you have only two nodes. One is head node, which is whose next is your tail node, and tail's node previous is head node. That is what I am doing when I am actually filling up this node, this class node LRU cache. It is its constructor. I am completing it. Now coming on to set. So you have to set node, a linked list node with a key and with a value, right? That's how your node is going to be. So before we move, I ask if my map, this was your map, if map contains, I am setting my value, if my map contains a key that has been passed here. If that is the case, remove it from the map. Why am I saying? See, when I have, let's say in my cache, I already have 1 2 and I want to add 1 5. So I will anyway remove this node and add a new node with key 1 and value 5, and that too at the MRU position, most recently used. So I don't care, wherever it is present, just remove it from the map also and from your linked list also, and then I will add it freshly at the most recently used position. That is why I am removing it from my map. Got it? Then you ask if your map.size is equal to capacity. You removed it. You ask next thing, is your map.size already equal to capacity? If that is the case, that means you have to get rid of node, and the node that you will be getting rid of will be present just before the tail. So just before tail I will be having node which is least recently used one, right? LRU. So this node will be removed. So this, how can I access this node? I can access by saying tail dot previous, right? So tail dot previous, remove tail. So this remove is the function that we are creating on our own, so which will actually go ahead and remove the particular node that I am passing. And then insert function will be inserting that key value pair as a node in my linked list. So insert new node whose key is this and value is this. Got it? So this is your set function. Now talking about get function. Get is all about asking your map, do you contain any key value pair with the key that I am passing? If it says yes, then what you have to do, then you know that value in your map will be of type node. So node current is map.getKey. Then first of all you remove that particular, because see, when I am calling my get function, I am actually opening that particular app again or a page again. Okay, so when I'm opening it, it will take its position in the most recently used. So from my linked list, I will remove it from wherever it is present, insert it using my insert function, and insert function's task will be to add that node right next to head. That is what I'm doing. So whenever I'm calling this get function, right, whenever you call get function, get using some key, int key, you are asking your map if it contains. If that is true, then what you are doing, first of all, you want to remove it from wherever it is present, then you insert that element and it will be added at the most recently used position. That is my insert function I am creating in such a way that it will take care that any node that I am adding, it will come at the most recently used position only. Got it? So remove, insert, and then finally, since you have to get the value, so you store that current, right? So current is your node that was present. So node is comprised of a key and a value. So cur dot value will give you the value that you want to return. If map does not contain this key, you return -1. Got it? Okay. Coming on to how we have implemented insert and remove functions. So insert function, whenever I am making call to insert function, I am making sure that I am adding a node right next to head node, right? So this is very easy if you know how linked list work. Otherwise, I will explain you what we are doing in each line. So whenever I am inserting a new node, I am making sure that it comes. This is your head node. Okay, it is pointing to whichever node. New node will be new nodes. Head dot next will be this new node. New nodes next will be previous will be this head node, and new nodes next will be the node that head was previously pointing to, right? Previous node, and previous nodes previous will be this new node, and rest things will be remain same because those are not disturbed. So when you are actually trying to insert a new node right here, these are the things that you have to take care of. So let's see how we are doing. Since you are inserting a new node, you are adding that key value pair, key and node pair in your map. Then you are storing head next. You are storing the right now head is pointing to which node. That node, that previous node's address, you are storing in a node by name head next so that you can access it. So head next contains head dot next. Then your head dot next is updated with the new node that you are adding. Then node dot previous will be your head. Now you have made connection from head to your new node, and from your new node to your head next and previous. Okay. Now head next that you stored previously, its previous should also be pointing to the node that you have just added. So head next dot previous is node, and node dot next is pointing to head next. So whenever you are inserting a new node, you have to make sure that its connection with the previous nodes is also done and its connection with the head is also done. So that is what we have done in your insert. And why we are inserting it right next to head? Because we have to make we are solving this problem in such a way that the most recently added node is present right next to my head, and the least recently used node is present right before my tail. Got it? Okay. Talking about remove, so you know whenever I'm calling remove function, I am removing the least recently used node, and I am implementing this data structure in such a way, as again I'm repeating, such that your least recently used node is present right before your tail. You remember this? Right before your tail is your least recently used node. So my remove function will make sure that the connection from this node to tail is demolished. That means you will store the address of node that is connecting my last node, right? So let's say this is your previous node. So previous node dot next will be tail, tail's previous will be this node, previous node. And how will you get this previous node? That is from the tail dot previous dot next. That's all. First of all, I remove from my map. Then node dot, this is the node that you are removing. So sorry, there's one mistake thing that I should correct. That I told you that we are implementing remove in such a way that we are always removing the node just before tail, but no, we have made a general remove function here, which is removing any node that you are passing in it. So how do you get address of the node right previous to that particular node? node.previous.next will be pointing to node.next. So sorry, how do you remove any node from a linked list? Is simply that function, it's nothing else. So very simple thing, you are simply removing that node.previous.next is pointing your current nodes.next, and node.next.previous should be pointing to node.previous. That's the connection that you are making. And that is all about this problem. So guys, if you have any doubts, you can ask me. Okay, so ultimately the entire question is that you need to understand how we are implementing this data structure. Then if you are aware of linked list, or even if not, you should understand via this problem what are the things we are doing. So this is all about this problem. Okay, so if you have any doubts, you can ask me. If not, see, in order to ensure that our expected time complexity for get and set comes out to be O1, these are the reasons we have gone ahead with map and doubly linked list. So we are done with this question. As I don't see many doubts here, let's wrap it up. Okay, fine everyone, see you all in the next lecture. Thank you and bye bye. This is the code, you can all have a look. That's how we have implemented the node for our doubly linked list. Fine. Okay then, take care everyone, see you all in the next lecture. Bye.